For the today's session, the main agenda of the meeting is that to explore the semantic kernel, that how to build the AI application using semantic kernel. So some of the agenda points that we would be trying to cover is that what are the AI orchestrators, what makes semantic kernel a tool that we should be using, different functionalities of semantic kernels, majorly function, planners, memory, and other features like persona, plugins, and hooks. These are some of the common features that are. So we will going a little bit of depth so everybody could understand it. So why semantic kernel is a question that you all will arise when you are building your application. So first we need to understand that why a role of an AI orchestrator comes to the place. So we know that we have been using LLMs in our daily life and also building products over it. Using multiple applications or directly using APIs from OpenAI and other tools like Mistral and all. But they are also very limiting in nature if you have used it. So you can be not be very repeatable in nature. The access of data might not be that easily possible. History maintenance is something that a headache of a software developer when you're building a system would be there. So their complaint is an AI orchestrator. So orchestrator, as the word symbolizes, it orchestrates different tools. So it comes around with the models and all the functionalities and play around with them to do the whole result part. So this is how an AI orchestration try to take place. Some of the major famous AI orchestrations are like the one that we are exploring, that is semantic kernel, LangChain, AutoGen are some of the tools. They all provide very similar optionalities, but in a very different package altogether. That AutoGen might be a multi chat framework. LangChain have its own set of features and functionalities. May some provide some different accessibilities, and there are multiple features. So for me, the better solution could be using semantic kernel. Let us explore why we would be using semantic kernel over other orchestration tool now as we. So when we go for features of a semantic kernel, we know that semantic kernel is one of the key framework that has been able to support both in Python, .NET, and Java as of now. .NET is in the production stage, and Python is also being released by the March end as in the production, and same goes for Java in the mid spring. Around that, it would be published. So all the three developers can easily work on their preferred language for say. So now let's explore what is it. So in the simple diagram, we were able to use it. So these are basic two things that we came to know. That is the connectors and the plugins approach. The plugins could be the triggers and actions, and connectors could be the memory models and all. So you can connect to it, and with the help of plugins, you can plug that into the semantic. So how the orchestration take place. So major features of semantic kernels are prompt templating, making reuse of the simple prompts that you are able to use so that you have now the repeatability to doing some action. So let's say you are building some application where you would be requiring some prompts. Prompts are basically the nature that how the things actually gonna work and to give the instruction to the LLMs and all. Function basically now you have already been in the templates and all. Now how to use it as a function. There's a new features of LLM. So there could be semantic function, non-semantic functions that you can easily plug and play with the help of providing that those functions to the LLM, and that would be a case that would be. Now comes that you have built multiple functions with the help of prompt templating. You are also doing semantic functions. Now how to automate all of them? It's then come the needs of planners that makes it automate the whole process. So there are multiple planners with their own set of features and advantages. So that's how the planners start to take place. Now you have all the planning stuff. Now if somebody wants to bring the memory part also, like semantic memory is also there. And now you have the cases of RAG, retail augmented generations, and multiple cases where you want to provide your live or maybe your private data to the LLM in the case where the LLM doesn't have. So that need of fine tuning or maybe even that need of building your own custom LLM is being solved by using memory and this planners and functionality approach, where multiple times LLM could be called, multi LLMs could also be utilized, and using those things, you can easily plan out the stuff and using only the LLM and not relying on the compute power alone, you would be able. Now, if you are using all these functionality, you might be able to use them in different places like our chat GPT, that is one famous that in the private version, that is the GPT 4 4.0 version. You can have the functionality of bringing out plugins. So you can also launch your own plugins with semantic kernel like Azure function. You can you can orchestrate everything and publish it in the public space, and now you can charge it accordingly or use in your own case. That's a different. Now when you're building, say, AI application, there's a character and persona. Like you're building a chef type API, chef type application, you want your LLM to have the persona of a chef for it, for that matter. So now you want to bring the character to your LLM application, because all the LLMs are very naive and basic in nature. They don't hold a proper persona. Now you, with the help of the prompt templating and the prompt that you give, you will giving it a prompt, and there you bring the persona. And one of the major features that currently been taking build place is the pre and post hook. So let's say you are building a function, but you want some tweaking initially or tweaking afterwards when the function is run. That can, like, some testing could be involved, some error handling could be involved, some different cases that could be involved, that you want some automation to be done when a function is being run. Like say uh, you made a function of email, so every time an email is being done, you want a logging to be taking place. Now with the help of pre and post hook, you can build like that. So let's get deep dive into every stuff in a little bit more details. So prompt templating, as already explained, is a basic text input that you majorly gives to your LLMs. And when you're dealing with all this stuff, you will say you would be making some case like let's just say in the example, I want to cook a very delicious recipe using the ingredient that suits my taste. So you would be giving the ingredients, taste, and all. So now it's an prompt template that could be reused eh, very repetitively by just changing the ingredients and the what the taste you want. With the help of the LLM, you can easily use that very rigorously. And now you have say a function that you can use, yeah, repeatedly, that with the help of changing of the ingredient and taste, you can now get different recipes from it. Okay, depending on the LLM and all the functionalities. So these prompt templating help us. So they make us format, reproduce, way to generate the prompt that can be support special type of tasks. So this is a special task that you want to build some recipes around it. So you don't need to rewrite the prompt every time just to change some few parameters. So changing few parameters is something like that is very useful by nature when you're building an application, because application will be needing to have some variables that will be changed repetitively. So with the help of prompt templating, you can utilize it. That is being utilized. So you have already built those prompts now. So now you would be having to use them as a functionality. So semantic kernel basically supports two types of prompts functions, that has a native functions and the semantic function. So native functions are basically things that are native to the your code. So let's just say you are using C Sharp, where say uh, most of the LLMs are not very good with handling mathematics or very complex math tasks in very general. You can have the sum operations there, but a very rigorous of operations could be very hard for the uh, for these LLMs, because how they are trained, because how they are built. The processing of math is something that is still not very good by most of them. So there are multiple actions where you can build your core functions and then provide with the help of their description, their use case, and the variables that you want to define every function, and then be utilized by the LLM. It will call dynamically by the LLM when they want to use it. So using that, you can have those functionality like the data collection, perform action, save information for that matter, like your LLM that you are being using, like chat GPT, that you might be using doesn't have the information to save the information into your own local database, but you want some functionality like that, you can easily build with the help of the native function. So you've already been explored over like let's say there's a semantic function where you have built the prompt template. So you want those prompts to be rigorously be used. So the prompt would be going there. It would be listened by the LLM models. So after the listening, they would orate something, and then it would be returning uh, as a response to you. So this is the whole functionality that you want to do some multiple action pre-made stuff could also be there. Like I've already listened about the cooking stuff. So this is something of a prompt function that you can, that a cook assistant could be something of a cook function could be there. So in the whole pipeline, when you are making something, some type of application, you might be having some cookery, and then the ingredient list is being provided, then the taste is being provided by the user, or maybe by the database itself that you are being using some native functions also. So these functions can also be connected, interlink with each other, and then perform the task dynamically and be connected to it. So there are also pre-made functions like summarization functions that can also be provided as a connector approach. So after making a function, you will making it to become a connector, so you can have them instantly available by the LLM to call them dynamically. And if you want them to launch it as a standalone service, you can now use a plugin approach. Plugins also, OpenAI plugins could also be, so they all support the whole terminologies and the whole naming scheme that being used by OpenAI to launch them very instantly. So now you have the whole functionalities of doing the functions, the prompt change, the prompting stuff, the native function being provided. Now you want to automate all those stuff manually. So calling which function should be called first according to the text provided by the user or the instruction provided by the user would be very hard to dynamically judge by the user. So let's just pass those responsibilities to say the LLM. So there are multiple things that able to do it. So as the image, so you have multiple tools that you out there. Now the LLM would plan around it. So planner could be of multiple types, that could be calling a single function, multi-function, stepwise function. So passing down the information in a sequential manner, a stepwise planner, or a handle break planner that has been currently in the build phase alone, where you will be passing down information. And if some actions been say the function doesn't play out what the want that you want, you would be pull the handlebar and it will be rerunning the whole process and replanning all the stuff. So that's how some planners are being built currently. So the replanning stuff, how those plan will work, how those steps will be performing one by one by one. So now you can build a more dynamic approach. So when a person asks something, let's just say I want to mail Naman uh, about the day, about the whole summary of this paragraph that I have provided. It will do the summarization function first. Then it will be finding my email from the connector that I have provided from that will be connected to our AD, and then with the help of email connector, it will be emailing it to me. And then after everything has been done, it will be returning a message that everything has been. So let's just suppose the mail doesn't have the information of, say, Naman has been not found in our Azure AD. So it will be responding it back with the help of handlebar that the number necessary find in the database. And then the user will be trying to say rechain it and using the history function of it. It will also now be replanning every step. So this is how the planners work. So planner allow not only all the functions, but also plans to pass down the process to multiple functions also. So a single functionality can also be used with some planners, and multiple planning stuff could also. So there could be plethora of say 100 functions that are out there. Now you can plan it all around it. And there could be action plan, like if a if the actions of the application is very less, you can use the action planner for that matter. If the needs are much higher, you might be switching toward more intensive applications like handlebar that is much more powerful in nature, but also cost some little bit of time, because every time the process is also big, every time the testing has been taking place, the redundancies are also there. So that might be a case when you are choosing those planners while building the applications that are there. Planners are correctly, there could be multiple loops that also be there, that in the case of stepwise or the handlebar planet for that matter. So currently phase, there are majorly three planners that are being currently in the production stage, or may say the 1.0 version, not in the beta stage, that are the action planner, sequential planner, the stepwise planner. Let's go in a little bit of detail to explain all of them. So when you discuss about the action planner, it is the fastest and one of the most low latency scenarios where you would be finding the best function that is out there to automate everything. So there could be like you can have a cook function, you can have a dish function, you can have some email function. So these all tasks might not be related to each other, but when a person be asking something, it will utilizing one. So uh, dynamically calling all of them. So there could be scenario where you'll be using the intent part. Intent is basically the intention of the person you want. So this action plan will be finding the intent, and with the help of your description that you have provided and the name that you have provided for the function, it will be providing what the function that need to be called that is out there. So it will automate everything. And out of the functions, tools, and plugins, so there are also multiple built-in plugins also that is in the semantic kernel. All the Microsoft actions that are out there, from the Outlook part to the Dynamics part, most of them are built, and even the GitHub part is already being built over it. So you don't need to design your own custom solutions over it and be having the rigorous testing around it. You already have those stuff, and with the help of the hooks, you can little bit of customization can be taking place according to your preferences and needs. So that's how action planners are being rated, that it will be finding the ideal solution that is out there, and it will be majorly choosing one only. So now the next step is the sequential planner, where the sequence of operations are being taking place. So it's a little bit more powerful, but also very plan intensive in nature, because multiple functionalities will now be involved in a sequential manner, where passing down the output from one to another is been taking place. So let's just suppose you would be providing now the planning is like that. You want to cook a dish, and you also well, let's just say you want the ingredients. Say you are having a poem about the cooks. So you would be first passing down in the cook, and then a joke a plugin would also be plugging there. So the joke around those dishes would be trying to take place. So what's your question is, then the cook would be deciding what you want to cook, and then around that dish you would be having a joke. So that could be a sequence of operation that could be out there. Accordingly, that's a naive use case that is out there, that you can try over it. And the capabilities of running everything in a sequence, output is one, where each information is passed down to other as the input chain. So inputting is the output of the other function that is out there. Now comes the stepwise planner. So let's just suppose you have written something. You will be breaking down everything into step-by-step operation, where not even the output, but also some specific information would be passed. Like just suppose the name is something that would be utilized by the email to find in the AD. So that might not be always the output of it. So uh, stepwise planner will also extract some text around it and will be passing down to differences. So step-by-step operations will be taking place. That is also sequential in nature, but also having the developer to easily design stuff where the information can also be provided in it. So where each plugins can dynamically call each other and pass down the information. So a single operation could take place, and a more complex interconnected task can be performed. Let's just suppose, as of a previous example, making out a plan to send a summarization could be a big task. So the summarization will call summary would be saved. Now the numming text would be searched by the AD. So those text extraction would be taking place to numming. The AD would be providing the AD functionality would be providing the email, and then the email part would be handling all the stuff of where to send, what should be the title, let's say the heading of the mail, and the body would be providing the summarization of it. So this all could be easily possible by the stepwise plan. And now the next one that is being currently not in the production stage is handlebar. That is one where you can pull the handlebar. So in the stepwise planner, if something fails, you would be returning back to zero and square zero, and you might not be have the operations to change everything. So there the handlebar planners take place into much more intensive where if something goes wrong, you would be prompting back to the user, and you would be able to see that how the goals are being pursued. So handlebar is technically one of the most superior version. It is a little bit of superior version of stepwise planner, but also very resource intensive, because every time a checking is being taking place, even after making a great plan, that is also very resource intensive by nature. So when you're using say action planner, you can use a very light LLM also. Like let's just say V2 could also be easily be able to work around. But on the sequential planner, stepwise, or say handlebar planner, you might be requiring a more powerful LLMs like GPT-4 or Mr. Large could be use cases in that, because the planning stuff should be very much powerful. So amount of stuff that has been provided, a good plan is the one that would majorly be successful. So when you're choosing what LLM would be making the plan, you might need to study around it and when building the whole application part. So now you have studied the whole applications of how they are being built. Let's just explore about the memory part. So LLMs may have the high amount of data by itself, but the latest data, the private data, and the contextual data that might be needed for that matter. Like just suppose you are being building a REST focused application. A person can ask what is cargo for that matter, but LLM will never be trying to navigate it towards REST. But when you are using rack side system, it will first find from the rack that okay, cargo is this, and we're providing the optional change. So you would be providing all the extracted data, and with the help of the RAG, it would be now LLM would know what the context of the data really matters. So even if the context has been not been provided by the user, with the help of the access memory part, you can provide it to the access over it with the help of RAG. Now comes the part of, let's say you are using your private or more new data has been provided. Let's just suppose you are having an updated database over which you want to provide something. So then a semantic memory would try to come into place, where with the help of the semantic memory you would be providing augmenting search. You can have cognitive search also. With the help of the cognitive planner of Azure Cognitive Search, you can provide your own documentation and all. With the help of the cognitive search, it would be providing it with all the use cases and all, with the help of the re-rankers and the ranking of all the chain, or all, let's say, the chunks that it were able to find. You would, with the help of how your application build upon, you would dynamically be selecting those texts, and then it will provide it in the prompt itself. And with the help of LLM processing, you would be getting the result. So semantic kernel doesn't only provide to use the semantic memory, but also to provide a semantic memory about the chunks part. So how the extraction, transformation, insights, and then it would be provided. So you might be providing some only PDFs, emails, chat, or even meeting reports only to it. So how semantic kernel also have the extraction features, how to transform them to the usable chunks, and then the insight over there. So the metadata comes into place. Then it providing into semantic memory and saving it to say a vector database, or a graphical graph database according to your needs and your own tech stack that you might be using. So when you are building all these processes, now a natural language question would be done there. A cognitive planner would be taking a use place. So a cognitive planner see that a memory is being needed. So semantic memory would be called. Then a RAG operation would be taking place, and after that a RAG operation answer with the citation part. So as I already explained in the case of the cargo part, uh, the process would be say that okay, rest memory could also be needed. Then the RAG would also providing the data, and with the help of the citation, it would be answering everything once and all. So these are the major features that are out there in the semantic kernel. Some of the latest development and some extra features that are out there would be explained in these cases with the other use cases that are out there. So the core functionality of semantic kernel has been explained. There's a memory planner, functions, and prompt templating that have already been explained till now. So as the plugins approaches say, you have already built a function for that matter, or your application as a whole could be something that you can repackage as an AI plugin. These AI plugin can easily be imported into the chat GPT, Microsoft 365 Copilot, Bing, all supported. So semantic kernel make a whole toolkit around it, so that the whole terminology used by the OpenAI and the whole standard in the AI plugin space is being directly imported into semantic kernel. So the talking with the data and all would be easy. So now you only need to expose this as an API with the help of say Azure functions, or maybe Azure applications, that, or maybe your own custom solution of the hardware that you might be using that could be out there. And with the help of your authentication and everything that you will be building over it, you can make and utilize it as a product also. So plugin encapsulate everything that is out there. It's take as an abstraction layer around it and encapsulate everything that is out there into a single pill for that matter. And in the plugin is being code, the native code can also be called, and request the AI services also via prompts can also be called. So how you're building the application, and this application can even utilizing the LLM itself to call it. So you can make multiple calls to LLM to do the whole the processes to devour it, and Microsoft already built some plugins over say the GitHub part, in the case of AI plugins, that can also be imported inside the semantic kernel for that matter. So you cannot also make your own plugin, but in your own application, you can build the pre-made plugin or even your own plugins also when you have been released it. So these can also be called upon and be integrated. So the whole suites of the application can easily be made. So the basic three of making an application are the plugins, the planners, and the persona for that matter. So when you're making a persona, you make fixated to an when you're making that changes you will be making in the system prompt itself, that the prompt that you will provide it. So how you would be able to handle that, how the whole nature of the prompt will be taking place, that how a person would be able to handle all of these stuff. So when building an AI agent, the persona plays a key role to define the task and its nature of execution. So a simple question of what is the recipe of it might not always develop the great result that is out there. But when you provided the persona that you're a master chef or level contestant, so now you would be making everything in a much more granular level in a detailed manner. So with the help of the persona, you can have the much more targeted nature. The consistency can also be there, and even the hallucination part can also be handled around it. So this is the latest development around what we say semantic kernel SDK that explore us to unlocking the new controlling features as a developer. So when you're making some functionalities that are out there, the customization is very much less granular in nature, because what is inside that function sometimes might not even be callable by you because you are using some pre-made function. So and now the pre-made function might not be that much useful because it doesn't solve your needs very specifically. Now comes the pre and the post hook for that matter. So how those execution take place, how those methodologies will be taking place. That so for that matter, like Outlook sending mail could be one thing that you haven't built, but before that you want to check the email that is fishy or not. You would making a pre-hook for that matter. You would pre-checking that okay, this mail is safe or not for our own organization. So now when you're building for your own organization, you are not only be utilizing the Outlook plugin, but also with a security layer of a pre-hook. So let's just suppose you have already built it. And in that use case, you have the mail is being given or not. You want a little bit of summary to be logged into your database. Now you'll be utilizing as a post hook where all the processing would be taking place and what's the result. So what the prompt is being going there, what the mail are being called, what the body of the message was. You can use everything in the post hook also to enhance its whole control. So this is how you can have the enhanced controllability of the whole, and with the help of pre-made plugins that are out there, and with the pre and the post hook, the whole customization level would also be taken. Now the event-driven architecture, like you have multiple events. That's the functionality. Then so before that, you can have the benefits of the tooling, that how the events are taking place, you can control over it. So when the events take place, then the only the pre and the post hook would be taking place. So the headed handling part, the event approaches that you might be taking place, the logging part that are out there, or might be recalling of every stuff could be there. Is a possibility that you can do with the help of the pre and the post hook. So tune in application behavior, handle error gracefully, and add functionality seamlessly could be an option around it. So we might now jump to the demo part of the whole application, where would be studying around how the semantic kernel actually being built upon. You can see before that we can start with some question and answers if you want to. Like in the current data, any questions from my queries from my side? If that, then do let me know. Um, no queries. So let's just start to explore about the code part first, and then we might take the extra queries that a person might be having around. So this is something. First, I would be explaining a very RAG-based code that I've built upon. and then exploring a simple base example that are out there. So we would be building a system where a user is being having a text-based approach. So when the token and the file is being provided, semantic kernel would be calling the LLM services to and the embedding services to chunk them all and embed everything into the vector database that is out there. And these LLM services that have been used to make are the locally been deployed using Olama or LM Studio that you can use according to your own preferences. So when the embedding is being done, you can now ask a chat request to it. So when the chat is taking place, the question answering part, everything would be taking place, and embedding text and everything would be going. And with the help of the embedding model, the embedding would be taking place and it would be searched in the vector database. So all the chunks would be find out which are much more relevant in nature. And these when are being done, it would be giving into a single prompt. And these prompts would be passing into say Olama for that matter, that might be running multiple LLMs like Phi2 or Tiny Llama for that matter, and will be providing a response. And this response would be taken back to the .NET API, and then API would be passing down into the user part. So first discuss about the API part, like how those everythings are being taking place. So there are the chat handler part, that how the chat is taking place. So we have built a chat logic part where the chat logic handles everything, and there's a document handling part. So semantic kernel say document to RAG is there. So if the file is not being supported currently, semantic kernel currently supports only three type of text format. That is, if you're not integrating, let's say uh, OCR into it, then only text, PDF, or docs is being supported out there. You would be first checking it. So this is the custom logic that I have written over it. So to check everything and all. So the API part is been taking place now. Say the domain logic that is out there. So how the document logics take place. So if all the chunking part or all the text conversion part is being done there. So if PDF is out there, it would be easily be readable, and then everything was being transformed into a single text file and would be saved locally. So the processing could be much more easier by nature. So this is the whole code around it, that how the dictionary taking place, and directly would everything would be able to save it and all. And with the help of interfaces, I have explored everything. So now jumps towards the services part, like how the actual semantic kernel works around it. So I have also made some custom logics, custom plugins. So custom Hugging Face plugins are also there. So semantic kernel currently runs support Hugging Face APIs directly. So having a custom based approach, so they explore custom logics or custom text embedding services that are out there. And similar goes for the Olama also there. So text generation services are used as a custom layer where you utilize all the tokens and the whole the nature. So get the text context asynchronization. Async could be a methodology that you take place, and all the model temperature, number prediction was the maximum token, but the prompt is out there, and the single signature I would also. So first say what how the loading part of everything comes into picture. So semantic text memory is the class that is being used by it. So how the text memory and the semantic memory has been utilizing. So currently we would be using Quadrant for that matter, like how Quadrant is the open source version of our vector database. There are multiple all other options that are like ChromaDB or Pinecone that you can use according to use cases. So first would be defining the embedding services. So when your text is being utilized, you might be able to, that might not be very much relevant for the say searching part, because a text can only be compared, but with the help of the embedding services, you can now embed into a vector format that could easily be compared by the memory itself and the search algorithm that are out there. So we will be having the first initialize the custom text embedding services. Then we would also be initializing the vector memory store. So when it would be stored around it. So now we'll be importing all those memories that are out there. How the collection kernel. So Quadrant has the terminology of collections. That's the, you can say a table. You can say it's a table, and the whole collection you can have information of a single type of data that is out there. So with the help of Blink 5 utilities, you will be chunking them all into different pieces, because a PDF could have thousands of lines, and each line have its own meaning for that matter. Now you would be chunking them all into various pieces, and with the help of the logger, we would be logging it, and with the help of the kernel.save information, you would be saving it. So the collection ID collection, then the ID is provided. ID is used to search when you're doing manual searching for that matter. The text and sentence is out there. Then you will be providing the message part. The saving of the message is being done there. So if some error is there, you will be returning back to the user, and it will be saving in the log aspect. So now you having done all the chunking part. So now chat service starts to take place, and the chat logic comes into the picture. So chat logics comes into the picture where you have the chat ID, user ID, and answer. So this is the whole format that has been followed in the custom approach. So to how to save in the database itself. So when you're having a so first you would be using the search service to search the what the input that you out there. So what the person inputted till it, that is the user query. User query would be passed, and the collection name that it would be using. So which collection the searching should be taking place in the rack. It would be taking place. So now this how the search take place. So now we know the query and what the collection you want. So first would be doing a search, we would be logging everything. Then with the help of the embedding service, we would be embedding the query that it itself into a vector that is out there. Then you were using with the help of the memory store to search it. So when you are using the searching a single query, there's a things called as relevancy and the search limit. Search limit is basically say how much text you want the. So let's just suppose you have the relevancy of 0.5, and there are 50 texts out there. So what's the closest? But you will not be needing 50 text because the character limit of LLMs are also out there. So to handle that, we majorly have a search limit that is out there. So let's just suppose we have taken a relevancy of 0.77. If you're using a generic text, 0.7 to 0.9 is something. If you're using very granular data, 0.9 to 1 can also be used. One might not be very effective because it's a exact matching that is not out there. So 0.8 or 0.9 should be a use case that you're out there, and search limit according to your preferences and the LLM that you are using. So let's suppose you are using Claude or Gemini for that matter. You would easily be able to use a very high amount of chunk data, but it will also increase the cost for the same. So using it, you would be doing it. So you're already getting the single line out there, but when you're using a PDF for that matter, there's always a paragraph that is. So to handle that, a custom scenarios take place where you will be taking two above line and two below line to make a whole paragraph for that matter and appending it to utilize it. So when the utilization of the chunk data is being found, a whole paragraph would be there. So the context is also being maintained that is there. So you are now search. Now what will be calling the LLM for that matter to use the chat service. So chat service first would be utilizing the Olama in that matter to do everything in the chat with LLM asynchronously. So you would be first defining the kernel. That the kernel is the main thing. So semantic kernel, as the name symbolizes, it uses a kernel framework where everything is connected to the kernel itself and everything connects with it. And all the memory part, all the plugins, all the functions will be called into it, and even in the planner is being called inside it. So kernel plans everything and execute with help of, and the planner then calls the kernel to take everything that is needed according to it dynamically. So kernel would first where we would be now you have initialized the kernel, we would be making it a build, now a chat template. So in the chat logic itself, it will be passing down all the prompt that is out there. Then a query would be saved in the log itself. Then the result would be taking place, and then if and what the result is out there, it would be resulted by the let's just say to the user back, and with the API, the person would be able to see. So the prompt is being made in a process like that. You are the general information the prompt templating part is being done. So memory is out there. So if something is not there, then it would be having a chat query. So AI response chat with asynchronously. So that's how it would be called, and all the memory and everything is being passed to it, and the prompt template is out there that you are a chatting system that try to solve everything. And so I'm using the prompt templating part. So the precise nature. So I have also defined that you are a professional. We have used persona of it. So it's a query solving application where you solve the query with the help of the relevant information that is out there from the chat. So we have defined the whole functionality with the help of the persona function or persona of the LLM in the prompt itself. So to handle it, we now use it, and with the help of the query and what the output is out there in the information, we're providing it. And now we'll be creating, when you're utilizing a prompt template, you might not able to directly utilize it. So you would be able to make it use with the help of the chat function. So you would be creating a function out there with the help of the chat template. And now you would be having say there are multiple inputs out there. So the terminology used in is a curly bracket 2 times and a dollar sign, and then the variable name that you want to utilize it. So then query, you would be utilizing it, and the information that you want. So these are the two parameters that you've already defined, and you can easily change it into it. So this is the whole use case that you can take place in the table of fact. So how the memory take place, how the injections take place into it, and all when taking place. So let's run a very simple case, and in the sense that because the rack would take a little bit of more time because it's running locally, so it would not be able to pursue it. So a simple use case that I have currently built over it is a simple console application where you would be directly be talking with the LLM itself that is running locally. So you will be writing in the step-by-step answers. So everything. So we would be using the kernel builder, and building would be taking place. Then the kernel will be built. We will be using the step-by-step answer, and then you'll be registering the what with the LLM with that would be using. So what the text generation service we will be using, we would be designing it, and it would be handling it, and then we would be building the whole kernel itself, and then creating a prompt function that we have utilized it. Right, so everything is step by step for that matter. And what the question that we are using, what is the capital of France? Let's just change it. Like what is cargo in Rust would be a question that is out there. Now run the whole system. So we're running it a little bit. It just expand the terminal so everyone would be able to see it very nicely. So we would be using .NET Run. Basically, then the custom LLM and the functionality will go like function input is what is cargo and Rust. It would be running locally because the system is a little bit at a clock, and we are using fee for that matter to run it locally. It would be because it's running a little bit more time because it's running locally, so it would take a little bit time to process it and all. So Olama cargo is a type of material. So as it already symbolizes it, it's a hallucinator. So that's how the sometimes things start to take place when you're using not when you don't provide a very simplified say persona is also not there and the rag is not there. So it symbolizes what is the material used and moved and everything is out there. System engineering, outlaw handling, and it would be explain the whole situation. So when you're using a little bit smaller LLMs and say different LLMs, then these scenarios might start to take place when you're using very generic scenarios. So let's just remove the previous example. Also can also be run. So you can have the Olama cargo as a material that's sometimes hallucinated a little bit when you're using very generic prompts and say you're not using much powerful LLMs that are out there. So the selection of LLMs and what's the rack that you might be using to give it a little bit of context that is out there that that symbolizes to make your application much more powerful and able to answer it and all. So yeah, it was able to answer some of the steps. So we are using like it also giving us the step by step because we are using what the steps are out there. So we'll be using the search engine such as Google. It has access over it, the provided access. So it will be having the France capital and all. Once the answers make you would be trustworthy, it will be checking it. So how the LLM actually processes it, and then it's provided as the step by step approach that has been out there because what's the prompt that we have provided. So if we are not using a prompt like a step-by-step answers, it would not be returning it. And so what's the context length that is out there and how you have written the prompt would make it answer it out there. So when you're building applications around it, you would be able to see that even if a slightly bit of change in prompt, like you might not have it written only answer this input that is out there. It might have not written such a huge paragraph that now when you're giving it out to the user, you might able to need to filter this out of information. That's a also edit step that are out there. So when the tools are provided, you also need to take keys into mind that how these how this prompt would be taken place. So a redundance testing, rigorous testing has been required. Like just say a step is out there, so it has using a search engine Google because we have provided it with that plugin that is out there. So we're providing it. So while building those application, you will always need to keep everything in mind that sometimes handling some simple case, you would be taking some edit checking and all. So then take place of pre and post hook would be required for this. So currently that is it for all from my side. Any questions and queries that I would like to answer that is out there. So if any queries from anyone's side that you want me to answer it, I would be happy to know. Hello.
Okay, so guys, if you're having any queries, then Naman is open to resolve them and answer them. Okay, so considering the silence has no over here, so I guess we are good to wrap up from here. Thank you, Naman, and thank you everyone for joining the session today.
just want to add one few things, Manshu, before we leave. Guys, I
Yeah.
hope everyone, there are two way to think of it. If someone is not having a query, either they are very much mature in it, or either something is not very much clear to them, right? So what to ask. So make sure, guys, please reach out to Naman or in fact to me if you are planning to do some experimentation in terms of RAG. If RAG terminology itself is not clear, then it's kind of like fine tuning on top of the existing one and not actually letting the LLM directly querying the LLM, right? So just go through the concept briefly. Might be a new concept for you guys, right? And lot of coding and lot of stuffs may be new to you guys. So just go through it briefly. You can share some references over the chat, Naman, so that it will be useful for the people to follow along. Very basic one, so that they can come up with good queries and we can help in building up the AI environment.
Yeah, I would definitely do that. Simple cases. Like there's a lot of Microsoft documentation out there, even the semantic kernel. They've recently revamped
Mm.
most of the documentation. Now they made very simple by nature. So if a
If you can give
Python coder
very
or a Java
simple,
coder
yeah. Just
have
provide the
also
simple
written two
one.
blocks
Yeah,
also.
yeah. Don't directly put the links of any Microsoft documentation. Keep it very simple. Any rough diagram will help them, right? So just want to make sure that people understand and make something out of it, of this discussion. Okay.
Okay, I will keep that.
Okay, so thank you, Anu, for guiding Naman on this. And Naman, you can share the documents as said by the Anu. With this, I guess we are good to wrap up from here. Thank you, everyone. Have a nice day ahead.
Thank you, Naman, for your time. Take care, everyone. Bye.